Yeah, hi, hello. We are in the measure phase, and according to our course, we are at module number 3. And module number 3 is all about measurement system validation and data collection plan. How are we going to collect the data? And then, do you really have a good measurement system, right? And this is called measurement system validation and data collection. There are so many topics under this particular module, and those are written here. And highlighted one I'm going to cover in this video, the basic statistics. And then I will also help you understand the difference between descriptive statistics and inferential statistics, right? So basic statistics. Fundamentally, statistics is nothing but presenting the information in the form of numbers. So statistics helps us in 3 ways. The first use of statistics is it helps us to summarize any data with the central value. We calculate metrics like mean, median, and mode, with which we actually understand what is happening, right? And we understand what has happened by looking at certain statistical measures, which are called the central values. So you can actually summarize the hundreds and thousands of data with some appropriate central value. We can also use statistics to assess the degree of variation, right? To assess the degree of variation. When you have 1000 plus data, and what is the degree of variation that exists within the data, right? And that also we can understand by you calculating certain statistical measure. And some of them are range, standard deviation, and variance. And we can also use statistics to understand the difference that may exist between two groups. For example, you have two machines and both are of same make and then same type. But still, no, when the machines are used to produce products, there could be some difference in the performance. If you wanted to validate the difference in the performance between machine 1 and machine 2, you should collect data from machine 1 as well as from machine 2, and then you can actually understand which machine is really performing better. So in essence, this is the application of statistics. Either you use the central value, or you use the degree of variation, or you use statistics to compare the groups and understand the difference that exists between two groups. For example, there is a statement here. A typical automobile in United States travels approximately 11,099 miles per year. That means it is understood that by collecting the enough data, it is understood that a typical automobile in US travels approximately 11,000 miles per year, isn't it? And similarly 9,300 miles for the bus and 13,942 miles for the truck. And same way you can express it for Canada. These are all applications of statistics, right? You have to collect the data and then you should summarize, and that summary is written here in the form of a statement, right? So statistics is the science of collecting, organizing, presenting, analyzing, and interpreting the data to assist in making more effective decision, right? So let's say you are doing a small study in a particular locality where the traffic is found to be very high. So you did a study over a period of time at that particular signal, and then you recorded the informations, right? And you found that after completing your study, you found that on an average 3,000 vehicles cross that signal point during peak hours. Out of the 3,000 vehicles, 1,350 are passenger cars, 600 are public vehicles, and then the 1,050 are two-wheelers. So which means, you collected the data and then you have understood, what is happening in that particular locality and particularly in that signal point. And this is nothing but statistics. You look at the statement, right? And you have numerically you have expressed the event, and which is called the statistics. So collection of numerical information can also be called as statistics. So when you actually do this kind of study, what do? You collect the data in a format. That format, we generally call it as a check sheet, right? And see here, you are entering the data like a particular, the date is captured, then total number of vehicle is captured, and type of vehicle is captured, and then after the completion of the study period, the summary is arrived, and then you actually presented it. And I mean, why you presented it in the form of a pie chart? Because you wanted to analyze, you wanted to categorize, how many are passenger cars, how many are public vehicle, and how many are two and three-wheeler type. And then you have interpreted the information in terms of percentage. This is what is called statistics, right? The science of collecting, organizing, presenting, analyzing, and interpreting the data to assist in making more effective decision. This is called statistics. And again, in statistics, there are two types. One is descriptive, another one is inferential statistics. You know what is descriptive statistics? If you have collected the data and if you try to understand what has already happened, then it is called descriptive. Suppose if you collect the data and then if you use the data and then by using the data, if you try to understand the future, then that will be called inferential statistics, right? We always collect a small amount of data, what we call it as sample, right? The place from where we actually collect the sample is called population. So after collecting a sample from the population, we study the sample characteristics to understand the population characteristics, right? If you are this study, this study with the help of sample to understand the population is generally called statistics. But then when it comes to descriptive and inferential, and let us take this example. See here the same signal point, and the study is conducted over a period of, let's say, 90 days. And then in a 90 days study, you understood that during peak hour, this many vehicles will cross the signal point, and out of them, this many will be passenger cars, this many will be the public vehicle, and this many will be two and three-wheeler. And this is actually descriptive statistics. You have described what has already happened. You are able to understand the characteristics of a population. Here the population is the vehicles that are crossing the signal point. But in order to understand the nature of the vehicles that are crossing the signal point, you did the study only for 1 hour, and then you are able to summarize. This is descriptive. So now you realize that the traffic in that locality is very high, and so a kind of overbridge is required. And so what happened? The plan for constructing the overbridge is arrived. And now if this overbridge is constructed, let's say it takes about 1 year from now. So after 1 year, how many people will get benefited? Now the same study can help you to predict the number of people who are going to be benefited by using this overbridge. And now the prediction is called inferential statistics. That means using the sample characteristics, you can understand the population characteristics, right? And if the population, if you want to understand the unknown characteristics of the population in the future, then it is called inferential statistics. If you use the sample just to describe an existing population, then it is called descriptive statistics, right? Hope it is clear what is descriptive and then what is inferential. If you are describing what is happening with the help of a data, then it is descriptive. If you are predicting what is going to happen with the help of the data you have in your hand, then it is called inferential. And see here, I have a statement. 3,000 vehicles are expected to cross the signal during peak hours. 45% of them are passenger car, 20% of them are public vehicle, 35% of them are two and three-wheeler. This is descriptive statistics because we actually got it by collecting the data from the field, isn't it? And descriptive statistics are the methods of organizing, summarizing, and presenting the data in an informative way. If you use the data to summarize the past population, your approach is called descriptive statistics. And see here, on an average, a person spent $1 or $3 on traditional Valentine's Day, in 2020. So how do you know this? You have studied this. And no, this is about what happened in 2020. That means, this is a descriptive statistics. The man spent nearly twice the amount women spend on a holiday. How do you know this? Because you have some data. You have understood the pattern. Generally, men spend, twice the money generally spent by the woman. So these kind of conclusions are examples of descriptive statistics. Now moving on to inferential statistics, right? If you use data to estimate future population, your approach is called inferential statistics. For example, you did a pilot study in your manufacturing facility. You observed something, and now if I run the manufacturing process in the same manner, then how my products are going to be. This is an example of inferential statistics because you have not manufactured. You just only did a pilot study, and then if you go for the actual manufacturing of the product and how your products are going to be, this is if you judge on that, that is called inferential statistics. So our main concern regarding inferential statistics is finding something about a population using the sample taken from that population, right? Inferential statistics are the methods used to estimate the characteristics of the population based on the characteristics observed in the sample. And that's why it is very important to collect data without measurement error and without sampling error. Otherwise, the inference you draw from your statistical report may mislead you. See here, using a sample to learn something about a population is done extensively in many business. That includes, your manufacturing and service industry, agriculture, sports, politics, government. It is very much applicable in all fields. See here, a random sample of 1,260 marketing graduates from a business school, were studied, and their mean starting salary was found to be $42,694. And so the graduates who are going to pass out from that particular business school, are expected to, have a mean starting salary of approximately $42,694. So based on what has happened in the last 4 years, we are judging on the starting salary of the graduates who are going to come out from the business school. And this is what is called the inferential statistics. And this is how statistics is basically helping us in making more effective decision making. Sometimes we do the statistics just to describe a population. We use statistics just to describe what has happened in our business. Sometimes we use statistics to predict what is going to happen in our business. If you use statistics to describe what is happening or what has happened, then it is descriptive statistics. If you use statistics to predict what is going to happen in your business, that's called inferential statistics. Hope all of you understood the basics of statistics, and then the purpose of using statistics. And all of us use statistics extensively, and so the statistical tools and techniques can help us in our business in a great manner to make effective decision. So we'll learn many more tools in the upcoming videos. Thank you for watching.